So we are back doing Trigo. Okay. And in Trigo, in this video, we are going to do Trigonometric Identities Part 2. In the Part 1, I had explained how the identities are formed and we had done the examples from NCERT. In this video, we are going to do all the important questions of NCERT only. And soon I will be uploading a video after this where I will be doing extra questions with respect to identities. But guys, if you had noticed a pattern in my videos, it is always that I always prefer to do first NCERT questions, and that should be the practice with you also. Okay, that means first make your base with NCERT questions, and after that shift to, once you're confident with NCERT that yes, you can do it without any help, then you should be shifting to other sources, be it any other book, Exemplar, RD, RS, or whichever other books you are referring. Okay. So over here right now, I'm doing all the important questions, and that is majorly question number 4 of the third exercise, that is 8.3 from NCERT. In this video, we will be covering these questions that are 10 parts, right? So now without wasting any further time, let's start with the first one. Okay. Now, the first question is cosec theta minus cot theta whole square equals 1 minus cos theta over 1 plus cos theta, right? So let's start. First of all, in this question, on the left, we have cosec and cot, but on the right, we have cos. I had told earlier also, whenever we are doing the identities, the first thumb rule is that 99% of the times, you have to convert things into sine and cos. And also, it depends what is given on the right hand side. On the right side, we have cos over here. So we will be converting left side to the terms of sine and cos. And let's see how do we do it. Cosec is 1 over sine, whereas cot is cos theta over sine theta whole square. I am just working on the left hand side, so I will just write left hand side as it is. Okay. Now, taking the LCM, the denominators are same. So that leaves me with 1 minus cos theta over sine theta whole square. Right? Now, what do we get over here? I will apply the identity over here. So that gives me 1 minus cos theta whole square over sine square theta. Okay. Now, when we say the word identity, it can be double meaning, because identity can be algebraic identity can be trigonometric identity. So when I said identity over here, I actually meant trigonometric identity, and that too in the denominator. Numerator I'm going to leave as it is over here. So 1 minus cos theta whole square. Now, what identity am I applying? Sine square theta. What is sine square theta? That is 1 minus cos square theta. Okay. It is this one. Now, 1 minus cos square theta. Remember your algebraic identity now. That is a square minus b square. It has two factors, a minus b into a plus b. So we are going to apply that in the denominator over here. And how that takes place? 1 minus cos theta whole square divided with 1 minus cos theta into 1 plus cos theta. I did a minus b into a plus b, where my a was 1 and b was cos theta. So now if you see, numerator and denominator both have 1 minus cos theta. So I'm cancelling out the denominator's 1 minus cos theta with one factor of the numerator's 1 minus cos theta, and that is square. I'm just cancelling out the square over here, right? So what do I get? I get 1 minus cos theta over 1 plus cos theta. And this is what we were supposed to prove. At the end, do not forget to write hence proved. Okay. So what I did over here, simply converted cosec and cot into sine and cos. And then I did not apply algebraic identity in the numerator at all. First, trig identity in the denominator, and then the algebraic identity again in the denominator. And you can see it is just 4 to 5 minimal steps, and we got our answer. We did not need to do anything related to right hand side. Okay. Let's move on to the second one. Now, the question is cos A over 1 plus sin A plus 1 plus sin A over cos A equals twice of sec A. यहाँ पे the things are already in the form of cos and sin on the left, whereas on the right, they have asked in terms of sec. We are not doing any conversion over here as of now, but we will just flow with the question over here. And that is telling us to take LCM because there is no conversion possible as of now. So LCM means what I'm going to do, I'm going to multiply these two cos squares and 1 plus sin A. Okay. So that gives me cos A whole square plus 1 plus sin A whole square over cos A into 1 plus sin A. This is how the LCM will take place, right? Now, cos A whole square means I can write it as cos square A. And now applying the identity of A plus B whole square on 1 plus sin A whole square. So A square is 1 square over here. 2AB is 2 into sin A. B square is sin square A. In denominator, I am not expanding, but leaving the parts as it is, that is cos A into brackets 1 plus sin A. Okay, I did not expand intentionally because I know things will ease out, things will cancel. And now what you need to do over here, we have cos square A plus sin square A. Whenever you see cos square plus sin square, it means first identity, that is their sum is 1. So what we get over here is 1 plus 1 plus 2 sin A over cos A into 1 plus sin A, right? Now I'll add these ones. So this becomes 2 plus 2 sin A over cos A into 1 plus sin A, right? Now we can easily see 2 is a common factor in the numerator, leaves us with 1 plus sin A over cos A into 1 plus sin A. 1 plus sin A, 1 plus sin A got cancelled. I am left with 2 by cos A. What is 1 by cos A? That is nothing but sec A, right? So that means it is equals to 2 sec A, and that was the right hand side, hence proved. What I did in this question, just took the LCM properly, applied A plus B whole square and a single trig identity of sin square theta plus cos square theta equals 1. And that's all. These are very easy questions. Do practice on them. Make yourself completely confident before hopping onto other books. Okay. Now, the third part. Third part says tan theta over 1 minus cot theta plus cot theta over 1 minus tan theta equals 1 plus sec theta into cosec theta. Now, on the left, we have tan and cot. On the right, we have sec and cosec. Everything is different. So, again, the first rule, convert things in terms of sine and cos. Let's start. So, tan theta can be written as sine theta by cos theta over 1 minus cos theta by sine theta. Then plus cos theta by sine theta over 1 minus sine theta by cos theta. Over here, I'm going to leave the numerators as it is and I'm going to solve the denominators, respective denominators. Okay. Sine theta over cos theta over sine theta minus cos theta whole by sine theta plus cos theta by sine theta over cos theta minus sine theta whole divided with cos theta. Now, I have told in earlier videos also, when you have fraction over fraction, how to solve that. I'll just quickly tell you, when you have a by b over c by d, it becomes equals to a by b into d by c, because the lower fraction is getting divided, and when you multiply, it flips. उल्टा हो जाता है, reciprocal हो जाता है, and that is why a by b into d by c. Okay, so I'm going to apply this rule over here. And let's do that. So what we get is sine theta over cos theta into, now the denominator sine theta went up and we have sine theta minus cos theta over here. I am now capturing them in independent brackets so as not to confuse ourselves. Then cos theta over sine theta into cos theta over cos theta minus sine theta. This is what we are getting, right? Now, what we get in numerator is sine square theta over cos theta into sine theta minus cos theta. This is your first bracket, outcome from your first bracket. And then cos square theta over sine theta into cos theta minus sine theta. Okay, we are halfway through. Now, it is an important step. Please pay attention what needs to be done over here. What we can see, in the denominators, we have cos theta, sine theta. Individually, they are different, right? Now the brackets, sine minus cos, cos minus sine. They are relatively same. Relatively, I'm saying over here because the terms are same, the powers are same, but there's just a difference of a negative, right? And in order to do that, what I'm going to do, I'm going to take out -1 common from the second bracket and replace this positive with the negative. Okay, so just pay attention to the next step, what I'm going to write. It becomes sine square theta over, we have cos theta and sine theta minus cos theta. Now, the center operation was plus. I'm going to write minus over here. The numerator remains as it is, cos square theta over sine theta. But now in bracket, which we had earlier, sine theta minus cos plus cos theta. Now I'm replacing that with sine theta minus cos theta. This change of slight operation, positive to negative, helped us by making the denominator brackets same. It is an important step in this question. If you don't do that, it is going to be a chaotic question by the end. Okay. So now what we do, we take up the LCM, and over here for the LCM, we can see the brackets are same. So we don't need to bother, but we will multiply this sine with sine square and this cos with cos square. Okay. So that gives us sine cube theta minus cos cube theta over sine theta into cos theta, and in bracket sine theta minus cos theta. Numerator shows us sine cube theta minus cos cube theta. Earlier you had studied an identity of a cube minus b cube, and I'm 100% sure with my experience that 99% of the students, when they are in class 10, they have already forgotten this identity. And I'm saying that this with my past experience. Do revise your class 9th identities thoroughly, okay? And they are going to help you in various questions in various chapters all throughout, not just in 10th, but in 11th, 12th, and always in future till the time you're doing maths. Now, a cube minus b cube, that was a minus b into a square plus ab plus b square. Okay, so I'm going to apply this identity in the numerator now, which is going to give me sine theta minus cos theta, first bracket. Second bracket results in sine square theta plus sine theta cos theta plus cos square theta divided with the denominator remains as it is. Now, what we can see, sine theta minus cos theta is same in numerator and denominator, right? And furthermore, sine square plus cos square we have in numerator. So that gives us 1 plus sine theta cos theta over sine theta cos theta. Though the question is not solved completely yet, we are just 2 steps away. But we can see from such a bigger portion, we have come to a very small portion, right? Now, I am going to split in the sense not splitting the middle term, but split in the sense splitting the numerator, that is giving each term of the numerator the respective denominator. So 1 over sine theta cos theta plus sine theta cos theta divided with sine theta cos theta. Okay, this cancels out. What are we left with? We are left with 1 by sine theta cos theta. Now, what is 1 by sine theta? That is cosec theta. What is 1 by sec theta? Sorry, 1 by cos theta. Sec theta plus 1. And if you see, this is what they had asked. So, we have proved. Hence, proved, right? It was a little longer portion. It involved a lot of simplification, fractional complications. We applied conversions of tan, cot in sine and cos. Then we applied the a cube minus b cube identity and further simplifications. But do practice it thoroughly. Now, the fourth question over here, which says 1 plus sec a over sec a equals sine square a divided with 1 minus cos a. On the left, we have sec. On the right, we have sine and cos. Guys, I'm giving you a minute. And meanwhile, just think what needs to be done. What should be the first step? And guys, when we are doing the questions with respect to trigo identities, the start of the question is highly important because it will give you the flow that how you're going to proceed. If your start is strong, you will be able to pull it through. You will be able to complete the question. But if you stumble in the beginning, if you do not do the correct steps in the beginning, generally it is going to end in a chaos. You may not be able to prove it correct, or you will make the question highly, very long, which is going to result in wastage of time. So just quickly think about it, what needs to be done as a first step. Now, I am going to convert sec in cos because on the right side we have sine and cos. So 1 plus 1 by cos a. Sec is a reciprocal of cos a. And over here also 1 by cos a. So what does it gives me? It gives me cos a plus 1 after taking up the LCM upon 1 by cos a. Right? Cos a got cancelled. I am left with only cos a plus 1. Can we do anything further to it? Cos a is just a single term. It doesn't have any square and we have 1. Right? This shows that we have completely simplified the LHS in this question. I told you earlier in the earlier video when I introduced identities that 99% of the questions you will just solve the LHS and you will be able to prove equal to RHS. But there will be few questions where you need to simplify both the sides, and this question is one such example. So I have solved the LHS. Now I will start working on RHS. And also just look the way I'm going to work, because this is the how you need to do in your boards exam or any exam when you're supposed to work on both the sides. I worked on LHS, but now you don't have to start your right hand side under the working, okay, under what we have done. Instead of that, you have to work on the right hand side. Equals. Now, this is how you need to work. That means your both the sides are being shown as if you worked on them parallelly. Okay. Now what is sine square A? I can write it as 1 minus cos square A. Denominator is 1 minus cos A. Again applying the identity of A square minus B square on top. So it gives me 1 minus cos A into 1 plus cos A divided with 1 minus cos A. And I can see 1 minus cos A, 1 minus cos A got cancelled. What are left? 1 plus cos A. So we have LHS equals RHS and hence proved. It was pretty easy question, but the only thing was you have to work on both the sides over here, right? Now, let's move on to the next question, which is the fifth one. Cos A minus sin A plus 1 over cos A plus sin A plus 1 equals cosec A plus cot A. Now, this is a longer question from this exercise. It is similar to the last example of your NCERT, which was example 12. Okay, it is similar to that. It needs to be done on the similar grounds. Okay, so let's start. And moreover, in NCERT, they have mentioned along this question that use the identity cosec square A equals 1 plus cot square A. So I'm going to use that over here. So pay attention how it needs to be done. Okay, first, left hand side has cos and sine, right hand side has cosec and cot. We need to convert things, right? We need to get out of cos and sine in this question. And for that, I'm going to divide. I'm writing dividing numerator and denominator by sine. Because I want cosec and cot. And cosec and cot both have sine as the denominator. So, writing each term carefully, cos A divided with sine A minus sine A divided with sine A plus 1 by sine A. Now the denominator, cos A by sine A plus sine A by sine A plus 1 by sine A. Okay, so what are we getting? We are getting cot A minus 1 plus cosec A over cot A plus 1 plus cosec A. Now, half the battle is already won because we converted cos and sine in terms of cosec and cot. Okay, so let's start working over here. Just a moment. Over here in the question, it should be negative. I committed a mistake while noting it down. Okay, so continuing with it now, what we need to do at this step, we need to multiply and divide with cot A minus cosec A. Okay, cot A minus cosec A, I took it from the denominator and we are multiplying and dividing with that. Now, we need to multiply each term of the numerator, that is a trinomial first and a binomial. Then we need to multiply each term of trinomial with each term of the binomial only in the numerator. Remember, only in the numerator. So, cot into cot gives me cot square A, right? Then cot into minus cosec gives minus cot A cosec A minus 1 into cot A minus cot A minus 1 into minus cosec A plus cosec A. And then cosec A into cot A gives you plus cot A into cosec A. After that, last term, cosec A into minus cosec A, that gives us minus cosec square A. This is just the expansion of your numerators. Don't worry, we don't have to do similar things in the denominator, but we will just keep them as it is. We will just keep the brackets as it is. And here we have it. Okay, now what can we see? Minus 40 cosec A plus 40 cosec A are available in numerator for cancellation. Right? I really enjoy when we get things for cancellation because it shortens our whole step and we have less things to write and less things to think about. So now we are left with cot squared A minus cot A plus cosec A minus cosec squared A. Cot square A minus cosec square A. What does this remind? The last identity. Okay. The last identity is 1 plus cot square A equals cosec square A. Right? And what we have over here? We have cot square A minus cosec square A. So that will be equals to minus 1. Now in the next step, I'm going to change cot square A minus cosec square A in minus 1. So let's start with that. I get minus 1 and then we have minus cot A plus cosec A. In the denominators, we had kept the brackets as it is, which was cot A plus 1 minus cosec A multiplied with cot A minus cosec A. Let me verify it was the same. Yeah, right. Now, what can we see over here is in the numerator, we have minus 1. Sorry, we have minus 1 minus cot plus cosec. And these terms are absolutely similar as we have in the bracket with just a difference of sign, which we can change easily by taking out minus common. So that leaves us with 1 plus cot A minus cosec A. And this is absolutely similar to your first bracket in the denominator. Right? Now, the brackets got cancelled. What are we left with? Now, smaller expression, which is just minus 1 over cot A minus cosec A. Minus 1 on top needs to be absorbed at bottom. That gives us 1 over cosec A minus cot A. But we have yet not achieved what they had asked. The right hand side was cosec A plus cot A. Okay. Over here, in order to get that, we need to kind of rationalize. That means we are going to now multiply with cosec A plus cot A over cosec A plus cot A. So now what do we get in the numerator? We get cosec A plus cot A. Denominator gives us cosec square A minus cot square A. I'm going back to the previous slide where we had written the identity. 1 plus cot square A equals cosec square A. So now if I take cot square A on the other side, I'm left with 1 and that is what we have over here. So now we are just ending the quotient and we have cosec A plus cot A divided with 1 and hence this is equals to your RHS. This quotient has multiple steps. It has a kind of a trick where you need to know that how we get into this step, right? This is the first step is yes, pretty important, but the second step is actually going to lead the flow of the quotient. So if you do not multiply and divide with cot minus cosec, you will just be left thinking what needs to be done over here. Okay, do practice it well. Now, the sixth question. We have 10 questions and we are done halfway by completing 5 questions. Okay. Now, if you want to take a break while watching this video, have a glass of water and pause the video, but do come back. Watch it till the end. Now, this is an easier one. We have square root of 1 plus sine over 1 minus sine. And on the right, sec plus tan. So that means left में sine है, right में sec और tan है. साइन को हम नहीं कन्वर्ट करेंगे. इंस्टेड ऑफ दैट वी आर गोइंग टू rationalize within the root, and it is an easier one. So now within the root, when I am saying, so I am making a bigger root, 1 plus sine A over 1 minus sine A into 1 plus sine A over 1 plus sine A. This is what we get. Now what we are having, 1 plus sine A whole square in the numerator. In denominator, we got 1 minus sine square A because of the A square minus B square identity, right? What is 1 minus sine square A? It is cos square A, right? Now, if you see, I can rewrite this step as 1 plus sine A upon cos A whole square, because ऊपर भी हमारे पास 1 plus sine A whole square था, नीचे भी we had cos square A. So I just took out the square outside as a common thing, such that now we can get rid of the square root and the square. So what are we left? 1 plus sine A over cos A, right? Now I'm going to split the numerator again, and that gives me 1 by cos A plus sine A over cos A. The last step, 1 by cos A is nothing but secant, and sine A by cos A is tan A, hence equals to right hand side, and therefore proved. Clear? Now, the seventh one. The question says sine theta minus 2 sine cube theta over 2 cos cube theta minus cos theta equals tan theta, right? So what we are going to do, I'm going to take out sine theta common from the numerator, leaving with 1 minus 2 sine square theta over cos theta common, 2 cos square theta minus 1. Sine theta was available in numerator as a common factor, and similarly cos theta was also available as a common factor in the denominator. Now sine by cos gives us tan, and that is what we want on the right hand side, but we want to get rid of the brackets in both numerator and denominator. So what do? This question is slightly different, because see now what we are going to do. We are going to convert the ones at our own convenience as sine square theta plus cos square theta. It is a different question because we are actually putting a value to 1. And how conveniently we are using the first identity, because everything we have is in terms of sine and cos. And that is why we are equating this 1 with sine square theta plus cos square theta minus 2 sine square theta, which we already have, over 2 cos square theta minus sine square theta minus cos square theta. It was a negative one, so I just changed the sign of the first identity. Now what we get? Tan theta is outside. I'm going to simplify sine square minus 2 sine square. That leaves us with cos square theta minus sine square theta over 2 cos square minus cos square. Again, positive cos square theta minus sine square theta. And I told you we have to get rid of these brackets. Now a same expression on top and bottom, and hence just tan theta is left. Therefore, proved. It was, I told you in the beginning, it's an easy question. This exercise and this question 4 especially, it's actually a highly important one, because it gives you a taste of all the sort of identity based questions, from easier to the challenging ones, right? Okay, now the 8th one. Sine plus cosec A whole square, cosec A plus sec A whole square equals 7 plus tan square A plus cot square A. What we do? I am going to convert this cosec. I'm going to apply the identity over here of whole square, A plus B whole square, in both the brackets on the left. So we get sine square A plus cosec square A plus 2 sine A cosec A. This is a square plus b square plus 2ab. And similarly, the second bracket, cos x square a plus sec square a. Oh, sorry, just a moment. The quotient is again written wrong over here. It was supposed to be cos a. Okay, then 2 cos a sec a. Okay, now collect sin square a plus cos square a. That gives you 1. What is cos x square a? 1 plus cot square a. Then sin a and cosec a are reciprocal of each other, but you need to show this step. Okay. Plus, what is sec square a? 1 plus tan square a. Then 2 cos a and sec a is again a reciprocal of cos a. What are we left with? 1 plus 1, 2, 2 plus 2, 4, 4 plus 1, 5, 5 plus 2, 7, and the answer 7 plus cot square a plus tan square a. था ना easy question, right? देखने में there were multiple terms, squares and all that, but just 2 steps and we are done. यही चीज अगर if you had converted that initially cosec and all that, things would have taken time to simplify. Now, we are on to the 9th question, that is second last. The question says cosec a minus sin a, sec a minus cos a equals 1 over tan plus cot. So what we have over here is we are going to convert things in terms of tan and cot eventually, right? First, I'm going to convert this cosec and sec in sin and cos respectively. 1 over sin a minus sin a. 1 over cos a minus cos a. Okay, what do we get? 1 minus sin square a over sin a, taken up the LCM in the first bracket. In the second bracket also similar, 1 minus cos square a by taking up the LCM. Because when you take the LCM, this sines will get multiplied, the cos will get multiplied. Okay, now what is 1 minus sin square a? That is cos square a over sin a into what is 1 minus cos square a? That is sin square a over cos a. We can easily see things are about to cancel out. Sin a get cancelled with the square, cos a cancelled with the square, and we are left with a simplified expression of sin a into cos a. Very satisfying, right? But we haven't achieved our answer. The right hand side said 1 by tan a plus cot a. That means we need to work on the RHS. I do not have space over here to solve on the right side, so I'm going to do it on the next page. So 1 by tan a, we had 1 by tan a plus cot a. I'm going to convert tan and cot in terms of sin and cos, which is quite evident. 1 over sin a by cos a, cos plus cos a by sin a. We need to take LCM in the denominators. So taking up LCM means sin will get multiplied, cos will get multiplied. So sin square a plus cos square a over sin a into cos a. Now remember, ulta ho jata niche wali fraction. So this sin a cos a goes up. And we have sin a cos a over sin square a plus cos square a. Now what is sin square a plus cos square a? That is 1. And hence sin a cos a is left. This is equals to LHS and hence proof. The question was easy. It took a little while because we had to work on both the sides. But it was quite satisfying to see sin a and cos a on either of them. Right? Now guys, just the last question. And this question is again slightly different as we have 3 sides onto it. Okay. That means I'm going to number, this is 1, 2, and 3. We are going to prove 1 equals to 3 and then 2 also equals to 3. So let's start working on the first one. It's a very easy one. What is 1 plus tan square A? 1 plus tan square A and over 1 plus cot square A. That is equals to sec square A, your second identity. In denominator, third identity, that is 1 plus cot square A equals cosec square A. Now what is sec square? 1 by cos square A over 1 by sin square A. So we will flip the fractions. Denominator sin square A comes up and we have like this, and here we get tan square A, that is equals to the third side. First part is done. Now let's start with the second one. We have 1 minus tan A over 1 minus cot A whole square. Okay. In this step, apply A minus B whole square in both numerator and denominator. So that gives us 1 plus tan square A minus 2 tan A over 1 plus cot square A minus 2 cot A. Okay, we can do this way also, or you could have done by multiplying or by converting tan and cot into sin and cos. Now, what is 1 plus tan square A? That is sec square A minus 2 tan A over cosec square A minus 2 cot A. Right? What is sec square A? 1 by cos square A. Eventually, I had to convert. So 2 sin A over cos A. This is just your numerator. Now the denominator, 1 by sin square A minus 2 cos A over sin A. Right? Now in this step, what we need to do, we need to take the LCM in the individual numerator and then individual denominator. So I'll just do that. We get 1 minus 2 sin A cos A whole divided with cos square A. And similarly, in the denominator, we will have 1 minus 2 sin A cos A whole divided with sin square A. And now we can see these brackets are same, so cancelling out. What are we left with? 1 by cos square A over 1 by sin square A. Again, same step where we need to flip the denominator fraction. So sin square A comes on top and cos square A in bottom. That is nothing but tan square A, hence equals to the third side, and hence proved. Now I'm writing complete hence proved because we have proved the whole set of 10 questions. This was a long video, but I have showed each and every question in the easiest possible manner. How do you tackle with them? So do practice well, watch each question, practice it well, and then move to the next question. I'm sure it is going to help you a lot. Happy learning.